Hi, my name is Johan Pedersen. I come from Ignion in Spain. We are the company behind the virtual antenna technology. And I'm here to talk about why the virtual antenna is preferred by many embedded developers. We're really thankful to be here at the Things conference. We had hoped to be physically with all of you. I must say being at CES in Las Vegas a couple of weeks ago was fantastic, and it's going to be an exciting year for IoT. We are thankful to be here with the Things network and with the whole community around it. Especially when we look at the generic node that many of you are using in your designs. We're excited to have the virtual antenna being on those reference designs. So you can see the red part in both the one here on the left, the white box, that is the generic node for sensors. You can see there's a red part on there. That's the antenna, the virtual antenna that is on there. And then on the black part, the black box on the right side, you see also a red antenna in there. That's also a virtual antenna. So when it comes to designing your next LoRaWAN nodes, I'm sure you're familiar with the advantages of using the generic node reference designs and all the resources that comes from the community. And in there, the virtual antenna is a part of that story. I wanted to make sure that you understand that story and understand why and what to do for your next design to ensure that you get a great, robust wireless connectivity in your IoT device. So the virtual antenna, you see one of them on this picture. It is a unique technology. It is a non-resonant antenna technology, meaning that the antenna itself is not resonating and is making the whole electronics design resonate. And if you compare to traditional antennas, they all resonate. This one don't. And this gives a unique suite of flexibility and characteristics and benefits that have not been possible before. It is a technology that is has been around for quite a few years now. We're approaching like 6-7 years in the market, and overall as Ignion, we have more than 30 million devices out there leveraging our antennas. But I want to make sure that you understand how to leverage it and give you an opportunity to use a unique service of ours free of charge for your next device. I will tell you a little bit more about that in a few slides. But first, an overview of the benefits of the virtual antenna and why embedded developers should really care. The virtual antenna and its wireless performance is defined by the matching network circuit and the PCB ground plane. So I also have a board here. So the virtual antenna makes the whole PCB become the antenna. It does that by taking the energy out of the RF module and igniting that into the ground plane, so that becomes your antenna. And it does so at a frequency defined by the matching network. So a few passive components, resistors and capacitors and so forth, that defines the resonance frequency of the RF system. And this gives you a ton of benefits. It ensures that you can get robust connectivity overall, so you achieve long range and long battery lifetime in your next design. It enables you to have predictable performance because we can simulate, and I'll show you the services around that later. We can simulate the final performance that you will end up in even before you do your design. And you can do that with multi-protocol, multi-band. So when you add an extra frequency band in the future of your device, you do not need to change your whole design, you can still use the same antenna. And it's an off-the-shelf package that is easy in production with very low lead times. And you can use the same part for multiple products and multiple frequencies. So it really simplifies your logistics. So overall, to think about the virtual antenna, it's virtual because the antenna part in itself is not resonating, but it's the PCB that becomes the antenna and thus the radiation of the RF signals. So this is quite unique if you compare to any other antenna technology, where other technologies are either off the shelf and easy to use, but then with questionable performance, or they are you can get really high performance, but it takes a long time to develop them. You need to invest a lot of NRE, a lot of engineering resources to get there. But with the virtual antenna, both of those things come in the same package. And that's why we are positioning the virtual antenna technology category on the complex, easy access and off-the-shelf and customized access as being all the way up here in the right corner, where you can see that it is a new category. It is not like traditional chip antennas where they are limited to a certain frequency range where they can be tuned and cannot achieve as good performance when you really integrate your designs. So the whole portfolio and the parts that are used in the generic node, you can see here. So any of these 6 devices, any of these 6 virtual antennas can be leveraged in your next design because they can all use any frequencies. They can all be tuned to any frequency depending on your board size. And the ones that are used in the generic nodes are the one here and the trio that are highlighted here. So the virtual antenna 1 is in the generic node sensor edition, and the trio is in the generic node tracker edition. So the difference between these two is that the trio has 3 ports. So in addition, for example, to your LoRa connection, you can have a Bluetooth or Wi-Fi and even GPS. So 3 different wireless connections in the same device with the same antenna, which is really strong. It makes it a lot easier for you to get the RF right. And to support you along the way, we have a lot of services if you need it. I don't want to go into details here, but just to let you know. And when you're designing your next device, I want to make sure that you consider that your PCB size has an importance for how high efficiency you can get on your RF system. And this is true for any integrated chip-like antenna, whereas the bigger PCB size, the higher efficiency you can achieve. However, with the virtual antenna, you can still achieve very high efficiency for very small device designs, because the virtual antenna technology enables you to squeeze out all the physically possible efficiency you would be able to get out of your design. And I invite you to read more about this in our application note that I have a link for here in the bottom of the page. But overall, you can just go to ignion.io and find our materials in there. But you can see here on the graph that we can get above 60% efficiency even on really, really small designs. 55 by 5 centimeters, and if you go up in larger designs, you can achieve more than 90% efficiency, which is really impressive when it comes to a lower design. So I invite you to come and try it out yourself for your next generic node based project or any other project for that matter. But for you who are participating here, we would like to offer it to you for free, that you go in on ignion.io/intelligence, and then you can get your own report with a full simulation of how your device would perform. We just need to know the PCB size and the frequency that you need. And then in 24 hours, we will get you back your next antenna design. So go and check it out, scan the QR code, and it will lead you to the page where you can just simply fill in the form, and then you will hear back from us. And when you hear back from us, you will get this report that will state exactly the efficiency curves that your antenna will be able to get. So you know exactly, okay, I will be able to get this efficiency and translate that into whether it will be range or power consumption or your key consideration when it comes to your next design. So overall, virtual antennas are preferred by embedded developers because of the robust connectivity it enables, the predictable performance, the flexibility in terms of multi-protocol and multi-band, and all coming in an off-the-shelf package. So that was sort of the key intro and highlight here for today that I wanted to make sure that you were all aware of, and as to why the virtual antenna is on there in the generic node hardware. It is because it makes it a lot easier for you. And the details of how to work with the technology, my colleague and one of the founders of Ignion, Johan, he will take you through the details in the workshop a little later today, where you can learn how to work with the virtual antenna technology in practice. So I invite you to join that in the LoRaWAN theater. It will be a really exciting workshop. Jaume, he's a great guy and also an antenna professor, so he knows everything about antennas. So please join us there. And other than that, just thank you for your time, and I hope I will see many of you in a couple of months when we get to the physical event. Until then, take care. Bye.